Hello everyone. So welcome to Mega's tutorial. Today we are starting with the fourth chapter, that is moving charges and magnetism of second year PUC. Right. So before I start the video, I request everyone who is watching the video, please subscribe to my channel, like and share the video with your friends. Well, coming to the syllabus, here we are going to study first the convention for current and the field. Convention for current and the field. So this diagram represents a current or the field emerging out of the plane of the paper, and this diagram represents the electric field or the current or the field going out of the plane of the paper. Means the current or the field emerging out of the plane of the paper is represented by the dot. It is depicted by the dot here, and the current or the field going into the plane of the paper is represented by the cross mark here. Okay. We are going to study an experiment here that is known as Oersted experiment by the scientist Christian Oersted. He gave an experiment to study this. In the first diagram, we are going to represent the alignment of the needle tangential to an imaginary circle which has a straight wire at its center. Imagine that the straight wire is passing through the center and it has its plane perpendicular to the wire. Means, suppose you imagine a wire passing through this center of the plane of the paper, then it is represented by the first diagram here. Okay. In this figure, the current flowing out of the paper is normal to it. Deflection of the compass needle is noticeable. Deflection means these are all the compass needles. Deflection of the compass needle is noticeable when the current is large and the needle is sufficiently close or nearby to the wire. Right. In this second figure, we are going to study the reversing. What happens when we reverse the direction? The orientation of the needle also gets reversed. It is represented by the second diagram. So, iron fillings were sprinkled around the wire. The iron fillings arranged themselves in the form of concentric circles. Say for example, if this is the field, when we sprinkle the iron fillings on this current or field, they arrange themselves in the form of concentric circles. In this way, the concentric circles form. Okay, this is how they arrange, that is in the form of concentric circles. Say this, consider this as the third diagram. Thus, from this experiment given by Oersted, he concluded that the moving charges or the currents produce magnetic field in the surrounding space. This is the conclusion of the Oersted experiment. Next, we are going to study about the magnetic field and magnetic force on a charge. The magnetic field and magnetic force on a charge, to say this, let us consider a charge plus q. Let us consider plus q is the charge. Let us consider a charge plus q. It is moving with the velocity v. The velocity of this charge is taken as v, and it is in the magnetic field B. B is the magnetic field. B is the magnetic field in which the charge q is moving with the velocity v. It is making an angle theta. It is making an angle theta with respect to the magnetic field B. Okay. Then the force experienced by the magnetic field, that is given by F B bar. In the presence of magnetic field, it is given by Q into V cross B. Take the vectorial notation here. FB bar is equal to Q bar into V bar cross B bar. or we can write this one as q v b sine theta. Okay, where theta is nothing but the angle the charge q is making in the magnetic field B. This is about the magnetic field. So this magnetic force or the magnetic field on a charge, it is having some features. Let us study about some features of this magnetic force. Coming to the features, the first one is, what are the features of this magnetic force? One by one, let us study the features. The first one is the magnetic force. The magnetic force on charge q, on the charge q, it depends on the velocity and the magnetic field. Depends on velocity, that is v, velocity v, and magnetic field, that is represented by b. Okay, so the first feature is, the magnetic force on the charge q depends on velocity v and the magnetic field b. The second feature is the force acts in the direction perpendicular to b and v, that is both the velocity and the magnetic field, velocity v and magnetic field b. Magnetic field. Okay. The third one is, force on negative charge is, force on negative charge is opposite to positive charge, and this force value vanishes. Force vanishes if velocity and magnetic field both are parallel or anti-parallel. Force vanishes if velocity and magnetic field are parallel. Parallel means theta value will be equal to 0, and anti-parallel means the theta value will be equal to 180 degree here. Okay. If an uncharged particle is moving in the field, is uncharged particle means in that q will be equal to 0. Uncharged particle is moving in a magnetic field, is moving in a magnetic field, then magnetic force is 0. Magnetic force is 0. Okay. Sixth one, the magnetic force is 0. Magnetic force is 0 if the charge is stationary. If the charge is stationary, stationary. Okay, so these are the some features. So still there are more, but 6 is enough, I think. These are the features of magnetic field and magnetic force on a charge. Next we are going to study the Lorentz force.